Okay, hello guys, welcome to Smart Somewhere Math Tutorials. So today's lesson will be doing Euclidean Geometry, which is for grade 11. And what I'm going to do with the lesson of Euclidean Geometry, I'm going to do like each video for each theorem, meaning as we have theorems from 1 to 9, meaning we're going to have each video for each theorem, meaning theorem 1 is going to have its own video, theorem 2 is going to have its video. And remember also that from theorem 1 to 9, we only have 5 proofs, or we're only required 5 proofs, or the theorems which requires the proof are only 5 from theorem 1 to 9, which is theorem 1, 2, 5, 8, and lastly, which is 9. Right, guys? So let's start with the business of the day. Sorry for that. Okay, guys. As you can see that we have the two diagrams, and I just label this one 1, and the second one is 2. So from the first diagram, we can see that we are given that AB is equals to what? BC, right? So always know that from the first one, we label. Always know that whenever AB is equals to BC, right? And then OC, OB is perpendicular to what? To AC. Okay? So from the first diagram, we can see that AB is equals to BC, right? And I just said whenever if AB is equals to BC, then OB is perpendicular to AC. You just have to know that. From the first diagram, we have OP, which is the line drawn from the center, and it bisects what? AC, or it bisects what? The chord, right? So we have the line which is drawn from the center, and it bisects what? The chord. So for the reason of this diagram, one is going to be the line from center is perpendicular to what? To chord. Okay, that's the first one, guys. So we're done with the first one. We saw that from the first diagram, we're only given that AB is equals to BC. And then the reason is line from the center is perpendicular to the chord, right? We'll explain it more after doing the second one. From the second one, we can see that we're only given the angles. From the first one, we're given that the sides are equal, or the lengths are equal. But then from the second diagram, we're given what? The angles. We can see that just know that whenever angle OP is equals to angle OPA, because they're both equals to what? 90 degrees. The reason from here is the line from center to to midpoint to the midpoint of what? A chord. Okay, I know someone will ask, why are those reasons different? Okay, from the second diagram, we're not given the lines, but then we're given what? The angles, which is angle OPC, as we will see that is equals to what? 90 degrees. And also angle OPA is equals to what? 90 degrees. So whenever we give a reason from that, we are going to say that the line from center to the midpoint of a chord. And remember, whenever we talk about the midpoint of the chord, so meaning that line which is drawn from the center, it cuts our chord into two equal planes. So therefore, it's going to form two angles which are both equals to what? 90 degrees. So lastly is that know that those two diagrams that they are the same, right? If angle AP is equals to angle PC, remember we said that if angle AP is equals to PC, then OP is perpendicular to AC, right? And from the second diagram, we can see that OP is perpendicular to what? To AC. So meaning even from the first diagram, P1 is equals to P2, they are both equals to what? 90 degrees. Remember that whenever we talk about perpendicular, let me write it here, guys. Sorry because of erroneous space. Okay, let me try to write it where we all can see it. Okay, let me write it here. We know that the sign or the symbol of perpendicular is like this, and whenever we have perpendicular, we know that these two angles here, which they are formed, are both equals to what? 90 degrees. So it tells you that whenever you're given that the length AP is equals to PC, automatically angle P1 and P2 are both going to be 90 degrees, right? So, and again, whenever you're given that, only if you're given the angles that are both equals to 90 degrees, then automatically the line AP is going to be equals to the line PC, right? Because of what? The line OP bisects what? The chord, which is line ABC. So it divides that chord into two equal length or sides, right? So for example, let's say from the example, we are required to calculate the unknown to calculate the unknown values, which are angle P1, angle P2, lastly line BC. Right, so the solution. Okay guys, remember from the theorems, most of the time they are not going to tell you that you have theorem 1, theorem 2, or even the statement, they don't tell you that, let's say, sometimes that OP bisects the chord, or that line from the center, it bisects the chord. So you just have to check whether do you have a line from this theorem one. You're going to check, do I have a line drawn from the center which bisects the chord? Yes, I do. We can see that OP is the line which is drawn from the center, and it bisects what? The line APC, which is the chord, right? So from what we just learned, we know that whenever if OP, you can see that OP, it bisects the chord, meaning it's perpendicular to what? To AC. And we said whenever OP is perpendicular to AC, we know that AB is going to be equals to BC, which they are both equals to what? 4 units. Right? The reason is line from center perpendicular to the chord. Line from center perpendicular to chord. That is our reason, right? So as we know that OP is perpendicular to AC, this line which is drawn from the center, OP is perpendicular to AC. What do we know about the symbol or the properties of perpendicular? We know that these angles which they are right here, which is P1 and P2, they are both equals to what? 90 degrees, right? So therefore angle P1 is going to be equals to angle P2, and both equals to what? 90 degrees, right? What is the reason? The reason is line from the center to the midpoint of a chord. Then we are done. So guys, from that example we did, I just wanted to show you that you'll be given a diagram, and sometimes you're not going to be told that the line OP bisects the chord, or the line drawn from the center bisects the chord. So you need to check those things from the theorem 1. So meaning you're going to check that, okay, do I have the center? Yes, I do have the center. Is it that center which is at the line OP bisect the chord? If you can say that, okay, that line OP bisects the chord, therefore you are allowed to say that AB is going to be equals to BC, and also P1 and P2 they are both equals to, they are going to both equals to be what? 90 degrees. So now we are going to do a proof of theorem 1, because theorem 1 requires the proof, right? So let's do the proof. I'm going to just erase here. Okay guys, from the proofs, remember from these two diagrams, you can be given that, or you can be told that prove that AB is equals to BC, which is the first one. The second one can be prove that angle OP, prove that angle OPC is equals to angle OPA, right? So remember it's ABC. Okay guys, let's say prove. From theorem 1, you only have two options, or you'll be given, from these two options you're going to choose one, or they're going to choose one, the examiner, right? So you need to know that whenever they say prove that AB is equals to BC, right? You'll be given the second diagram. And if they want you to prove that angle OBC is equals to angle OBA, you'll be given the first diagram. I don't know, understand now. If whenever they want you to prove that AB is equals to BC, remember from the first diagram, already we know that AB is equals to BC. So you can't prove this thing because it's already there. So, but then they're going to give you the second diagram whereby AB and BC is not highlighted that they are equal, or they are not given that they are equal. So you must prove that the line AB is equals to the line BC using what? This 90 degrees and the other angles both sides, right? But then you're not going to use AB is equals to BC. And if they say prove that angle OPC is equals to angle OPA, you'll be given the diagram like this. You'll be given that the line AB is equals to the line BC, so that you're going to calculate what the angles, or you're going to prove that these two angles, which is B1 and B2, they're both equals to 90 degrees. So for us now, let's prove that AB is equals to BC, right? And I'm also going to show you whether if they say prove that angle OBC is equals to angle OPA. There is a little different from proving those two, but then let's do the first one, and then I'll also show you how do we prove whenever they say angle OBC is equals to angle OPA, right? Okay, guys. So prove that AB is equals to BC. Like I said, whenever they say they want you to prove that AB is equals to BC, you'll be given what? The second diagram, which has what? 90 degrees. And whenever they say to prove that angle OPA is equals to angle OPC, you'll be given what? The first diagram, right? So how do we prove this? The first thing from theorems, guys, it is important to construct. We are going to construct. That's what we'll be doing. We're going to construct. So, okay, let me write here solution. Okay, wait. Okay, guys. Here it is. Prove that AB is equals to what? BC. Like I said, whenever they want you to prove that AB is equals to BC, they are going to give you the second diagram, right? But if we're about to prove that angle OPC is equals to angle OPA, we're going to be given the first diagram, right? So I'm going to do this one, but then after I'll explain what happens whenever you are given that, or whenever you are required that prove that OPC is equals to angle OPA, right? So the first thing in theorems, guys, is to construct. It is important to construct. So from here, we are going to construct the line OA. We're going to construct the line OA and the line OC. Right? After, you need to write them down. You need to write down, okay, construct. Whatever that you do, guys, you need to write it down. Construct OA and OC. And OA, guys, it's a radius because it's a line drawn from the center which touches what? The circumference, right? So it's the radius. And also the line OC, it's a what? It's a radius. And whenever we have the radius, the lengths of each radius are equal, all of them. meaning line OA, or the length from O to A, is equals to the length from O to C. The reason is the radius, the radii, because of those two lengths are what? Are the radius, right? So after constructing OA and OE, we did this so that we can have two triangles. You can see that now we have triangle OPA and triangle OPC. Let's not talk about OEC, guys. Let's just focus only on OPA, meaning we now have in triangle, we're going to talk about triangle OPC and triangle OPA, right? So meaning it's triangle OPC and triangle what? OPA. I hope you do see them, guys. So after writing this statement, you are now going to prove what? Congruency. It's from grade 9, guys. We are now going to prove congruence. So from OPA and OPC, what do we have in common? Okay, the first thing we can see that the line OP, it's common. You can see that the line OP is common, right? So the second one, we are given that angle OPC is equals to angle OPA. Reason is that both equals to 90 degrees. Or someone can say, given, it's also allowed to use this one. You can choose either both are equals to 90 degrees or given. We can see that OPC is equals to 90 degrees and also OPA is equals to what? 90 degrees, guys, right? So the last one, we just talked about the radius. You can see that we have the line of OA, which is the radius, is equals to the line from O to C. The reason R is the radii. Whenever there are more than one, then we say radii, but whenever it's one, we say the radius. So we know that OA is equals to OC. Then, in conclusion, triangle OPC is equals to triangle OPA. We need to put a reason, guys. So how do you find your reason? What did you first write, or what did you first prove that, okay, this thing is equals to this? The first thing we said that OP is common. Is OP a side or angle? It's a side, therefore we write what? The side. From the second one, we proved that angle OPC is equals to angle OPA, which they are both equals to 90 degrees, meaning we proved what? An angle, therefore we write angle. Lastly, we are talking about OE and OC, which are the sides. We write it down. So meaning the reason of congruency, remember congruency has 3 lines, sorry for that. It's side, angle, side. So therefore meaning AB is equals to BC. Then you are done proving. You are done proving. After proving congruency, for the theorem one, after proving congruency, the main point about theorem one is that you are proving congruency, meaning the first thing that you're going to do, you're going to construct so that you can have two triangles, so that you can be able to prove what? Congruency. That is the theorem. That is the theorem one. It's about proving congruency. meaning you need to have two triangles so that you can prove what congruence. So we can see that we first constructed OA and OC. We did that so that we can have what? Two triangles, which is in triangle OPC and triangle OPA, right? Then after, as we have those triangles, we are now going to prove what? Congruency. It's going to be simple for us. And whenever we prove congruence, we know that it's either the reason is going to be, we're going to prove it's either side 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 or side angle angle or side angle side, right? So we saw that OP is common, that's what we wrote. And then after we saw that angle OPC is equals to angle OPA, which are both equal to 90 degrees. And again we saw that angle OA is equals to angle OC because they are what? They are the radii. We proved three things. Then after we concluded that OPC is congruent to triangle OPA, the reason is side angle side. Therefore, AB is equals to what? BC. So let's say you were required to prove that angle OPC is equals to angle OPA. So what you were going to do, you are going to follow all these steps, but except for where we set OPC is equals to angle OPA. Because remember now we're proving it, so meaning we are not supposed to include it. So but then, like I said, whenever we prove that OBC is equals to OPA, we'll be given the first diagram. If we check from the first diagram, we can see that AB is equals to what? BC, meaning from what we wrote there for OPC is equals to OPA, both equals to 90 degrees or given. We're going to replace it with what? AB is equals to BC. The reason is given, right? Therefore, after proving it, at the end, we're going to conclude that we're not going to say AB is equals to BC because already we've used it here, but then we're going to say angle OBC is equals to angle OPA because Kim reprove. So we are done with theorem 1 and the proof of it. But lastly, guys, about theorem 1, I want us to check this. Let's not forget this thing. From what we just proved now, we can see that okay, we now know that, okay, let me use this one. We constructed line OA and line OC, right? Wait, guys, let me do this. I want you to show you something so that you have to think out of the box whenever you are doing what? You're doing Euclidean geometry. Okay, guys, we have this line which we just proved that we constructed OA and OC, right? And then we proved everything. But now we know that this line OA is equals to the line OC. We know that, right? That the line OA is equals to the line OC. They're both what? They radii. So meaning, can you guys see triangle OAC? Can you see triangle OAC? Triangle OAC, whenever, meaning OA is equals to OC, we have two sides which are equal and then one which is not equal. So meaning, from the properties of triangles, we have what here? Isosceles triangle, meaning this angle here is going to be equal to this angle. So it is important, guys, whenever you are solving the questions of Euclidean geometry, to check, to construct if you need to, but don't construct a lot because it's going to confuse you. You can construct like you're proving that EB is equals to BC. After constructing, we can see that now we have what? We have triangle. and not only a triangle but an isosceles triangle. And what do we know about isosceles triangle? We know that the angles which are opposite to those equal sides are what? They are equal. So meaning angle OAC is equals to angle OCA, right? So that's it about Euclidean geometry and for theorem 1. So we'll be doing theorem 2. You can check the other videos for theorem 2. So for now, if you have any question in theorem 1, you can leave a comment behind. Anyways, thank you guys.